Hello, and welcome to the third episode of Automat DEVLOGs. Today I will talk a little bit about progress in Automat, obviously, and then also about the design process that I'm using here. We are working on the assembly object. To actually implement it, we will just need three components. There will be one subobject representing an instruction, one subobject representing an instruction library, which will allow you to build new instructions. This is how it's going to look like, roughly. It's a work in progress. And lastly, the assembler, the object which is actually going to convert instructions into machine code and execute it. The instruction library, which currently looks like that, but I will actually show you step by step how we kind of got here. The big problem with assembly is that there are just a ton of instructions that can be parameterized in very different ways, which are not always super regular. Instructions are not completely orthogonal to each other. Sometimes when you select one register, it prevents you from selecting some other register, but only in some instructions. It's mostly regular, but it has exceptions. It's like a language, really. When I started working on this, the first idea was to come up with a sort of filtering, or something like a decision tree, that will allow us to drill down. So this is an interactive prototype, which shows a table which contains some instructions and allows me to filter. For example, I can select that, hey, I want only the add instructions. There are still quite a bit of them. I want them to operate on 64-bit operands, and I want to, for example, write to arrayx register. And now this set of instructions is fairly manageable. This is an interactive prototype done in JavaScript, just to see if this idea works. After we got this, we switched to some visual brainstorming of how this could actually work. Because this table is huge, it cannot be practically used. We need to actually compact it, we need to optimize this design. So this is the next idea, where we will visualize instructions instead of a table as a deck of cards, rotated slightly in this helix shape. Each category of instructions will be selectable as a flag, kind of extending out of the instruction stack. And various filters will be selectable using a large array of buttons. I'm doing it this way because I want to optimize the speed, like how fast you can select the instruction that you are interested in. So you will be able to quickly click like two buttons, select the category, and then by moving mouse over the deck of instructions, you will be able to quickly select the one that you are interested in. So once we had this, we actually started prototyping this with image generators. I call them collectively Stable Diffusion, although I practically don't use Stable Diffusion anymore. It's mostly Flux in my workflow. So we came up with this idea of imitating the Monty Python style, which, if you actually look into actual Monty Python sketches, they are mostly gentlemen being contrasted with naughty stuff. So the way we went here is, instead of imitating Monty Python style directly, we're trying more of a modern take of Monty Python. This is still a collage, but we are using images generated from Stable Diffusion here. So each register is implemented as a squad of units in a square formation. They hold flags. This means that they are part of the register. A flag is a symbol of a register here. In this array of buttons, you can select the register which you can write or read from, and the size of the subregister that you want to select. Specific categories of instruction can be selected by clicking on flowers, which will then extend and show you the subcategories as buttons. Yeah. So this is how this was created. We have one more small update, and this is the assembler. We actually moved the prototype for the code that we've seen last time into Automat proper. So now we have something that can be executed. So this object here, this is the instruction, and when I will execute it, the assembler, which holds the state of registers, will update. So when I run this instruction, the assembler updated. Incredible, right? Okay, the design process that we are using here. I would like to quickly mention this because I think this could be interesting. First step is to understand the problem space. I am not an expert in any really problem space, so usually I have to consult documentation, I have to check some books, and this is what I've done in this case. After doing that, I've done the brainstorming of how the layout could look like, and this tells me about potential problems that we will encounter, like is it possible to fit everything on screen? Next step is the prototype. So this is the stuff that I've shown you again last time. This is when we had a piece of LLVM code executing. In each of those stages, I often have to go back to the book or to the documentation to update my knowledge. I guess this is obvious. Those two things can happen in parallel. Once I'm done with brainstorming, I can move on to design, where I try to more concretely predict how it's going to look in the final product. And this is what's the current state of the design. In parallel, on the other side, there is the object implementation, where I try to actually implement this object, which is here. And once those two are done, we can move to probably the most interesting phase of this whole process, which is to actually implementing the widget with all of the interactivity, all of the physical simulations. The widgets which are part of Automat are probably a good example of how this looks. This is it for this devlog. I will talk more about how I design stuff with Stable Diffusion, maybe in the next episode. So, see you then. Bye.